All right, today we're diving deep inside the engine block to talk about an unsung hero of the high horsepower world. It's a clever bit of engineering that stops the most powerful engines out there from literally tearing themselves to pieces. We're talking about cross-bolted main bearings. So let's start with a big question. You've got an engine making, say, 1,000 horsepower. What's actually keeping the incredible forces of combustion from ripping the crankshaft right out of the bottom of the block? Well, the answer is a whole lot smarter than you might think. Think about it. Every single time a cylinder fires, that explosion slams the piston down. That force travels through the connecting rod and shoves the crankshaft, forcing it to spin. And the only things holding that violently spinning crank in place are the main bearings and their caps. They are the absolute foundation of the engine, and they are under an unbelievable amount of stress. Now, you'd think the solution is just, add more bolts or maybe bigger bolts. But that really only solves part of the problem. The real answer is a smarter, much more robust system of multi-directional support that basically creates a cage around the engine's spinning heart. To really get why the solution is so brilliant, we have to understand the problem first. So let's take a look at what happens when a standard engine's bottom end gets pushed way past its design limits, right to its breaking point. So when you start pouring on the power, we're talking turbos, superchargers, you name it, you introduce some really serious risks. The main bearing caps can actually start to wiggle side to side, which is a scary thing called main cap walk. This can throw the crankshaft out of alignment, which chews up bearings and leads to, catastrophic failure. In extreme cases, the entire engine block itself can start to flex under the load. Let's really zero in on the main villain here, main cap walk. We are talking about tiny, microscopic shifts, stuff you can't even see. But that little movement is incredibly destructive. It messes up the perfect circle that holds the bearing, and it squeezes out that critical film of oil that keeps the metal parts from grinding against each other. And once that oil film is gone, things go from bad to worse really, really fast. And hey, don't just take my word for it. The folks at Engine Labs put it perfectly. When a main cap starts to fail, the crank begins to walk away from the bearings. Oil pressure goes away, and things go boom. Yeah, it's a chain reaction that usually ends with the inside parts of your engine suddenly deciding they want to be on the outside. So why does this happen in the first place? To figure that out, we need to look at the standard foundation for most everyday engines and really understand why 2 bolts, which are perfectly fine for your daily driver, just don't cut it when the power gets serious. Okay, so a typical 2-bolt main clamps the cap to the engine block with just 2 vertical bolts. This is great for handling the up and down forces you see in a stock engine. The challenge, though, is that a high-performance engine also creates these powerful side-to-side and twisting forces, kind of like wringing out a wet towel. These other forces try to shove the cap sideways, completely overwhelming that simple 2-bolt design. And this is where our hero, the crossbolts, finally enters the story. To fight back against all these forces coming from different directions, engineers came up with a way to create what is essentially a cage of support right at the very core of the engine. The concept is actually brilliantly simple. In addition to those regular vertical bolts, you add horizontal bolts. These go right through the sidewalls of the engine block, sometimes called the skirt, and they thread directly into the sides of the main cap. So the cap is now locked in place not just from the bottom, but from the sides too. What this does is create clamping force from 2 directions at once. You've got the main bolts pulling the cap down vertically, nice and tight. And then you have the cross bolts locking it in place horizontally from the sides. The result? You get one incredibly rigid, unified assembly that just refuses to twist, flex, or do that destructive main cap walk. So we've basically built this super strong cage around the crankshaft. Let's dig into the specific mechanical advantages this stronger core actually gives us. This design directly attacks all the problems we talked about earlier. It ties the whole crankcase together, which makes the block much more rigid and resistant to flex. It anchors the caps from the side, which flat out stops main cap walk. And by doing that, it keeps the crankshaft spinning perfectly true, which means less vibration, less wear, and a much, much more durable engine in the long run. Now, this isn't just some theory on a whiteboard. It's a proven design you'll find in some of the most legendary engines ever built. So let's check out a few real-world blueprints of power to see how it's actually done. Cross-bolting is just one of several ways to beef up an engine's bottom end. A 4-bolt main, for example, adds more vertical clamping, but it still doesn't stop that side-to-side flex. The cross-bolt is what provides that crucial lateral rigidity. Then, at the really extreme end, you've got something called a bed plate. Just imagine all the individual main caps are fused together into one giant, super strong ladder frame. It gives you total structural integrity, but it also makes servicing the engine a much bigger headache. Okay, one of the absolute coolest examples of this comes from Ford's modular V8 family. It's a fantastic look at how two different factories came up with two different solutions to the exact same problem. For years, Ford built these engines in two plants, Romeo and Windsor. Both used cross-bolting, but they did it in completely different ways. So the Romeo plant, which was building Mustang engines, used this really clever jack screw design. Think of it like the little adjustable foot on a wobbly table. After they installed the main cap, they'd tighten a small screw outward from inside the cap, pressing against the block wall to create tension. Then they'd install the crossbolt from the outside, locking it all together into this incredibly rigid, pre-stressed assembly. It's pretty genius. Meanwhile, the Windsor plant, which was building truck engines, went with a simpler, faster method that was better for mass production. Instead of those adjustable jack screws, they used fixed, tapered dowel pins to get the alignment right. They'd torque the vertical bolts, hammer the pins into place, and then install the cross bolts to a higher torque spec. It's two totally different philosophies to get to the same exact goal, a rock-solid bottom end. And it definitely wasn't just Ford. GM's legendary LS-V8s, the ones in everything from Corvettes to pickup trucks, they all feature 6-bolt main caps, 4 vertical bolts, and 2 horizontal cross bolts. Even Toyota got in on the action with their incredible 1UZ FE V8. That engine was famously over-engineered, borrowing its 6-bolt design straight from a race engine to achieve its legendary smoothness and durability. So, after all this deep dive engineering talk, what's the big takeaway here? Why does any of this matter to somebody who just loves powerful, durable engines? Okay, here's the bottom line. Cross-bolted main bearings provide the strong foundation you absolutely need to safely handle huge amounts of horsepower and torque. They make sure the engine is stable at high RPMs by keeping that crankshaft spinning perfectly true, and ultimately by cutting down on vibration and wear on the most critical parts, they just make the engine last a whole lot longer. It's the engineering that lets a performance engine survive. But technology never, ever stands still. We've already seen designs like the bed plate, which takes that structural integration idea even further. So it leaves us with one last question to chew on. As engines continue to evolve, will these newer, more integrated designs eventually make the mighty crossbolt a celebrated but ultimately outdated relic of the past? It's something to think about.